Hi everyone, good afternoon. Thanks for joining us here for an Alteryx webinar with Billigence. I'm Blake Lamond, Data Science and Visualization Lead. I'm joined by my colleague Alex Cavallo, Machine Learning Consultant as well. Today we'll be discussing clustering, time series forecasting and linear regression, and showcasing some of the tools from the Alteryx Predictive Tools Suite as well. Okay, first a little bit about Billigence as well. Who are we? We are an international business intelligence consultancy with offices in Australia, the US, Asia, and Europe as well. So we specialize in business intelligence and data challenges as well. And so we focus a lot on self-service analytics and lots of other aspects of data and BI as well. Our BI practice focuses on 5 pillars: data consolidation, data governance, predictive modeling, which we'll be focusing upon today, data visualization, and automated customer relationship management as well. We work with large clients across a wide variety of industries as well, in the telco space, finance space, retail, and others as well. We provide our expertise and assistance for all of their challenges as well. So we also have long-term partnerships with data solution providers as well, with Alteryx Connect, Tableau in the data visualization space, Alteryx as well, and Snowflake as well. So, okay. So today we'll be walking through some of our predictive analytic techniques as well, and applying them to some sample data sets, and showcasing the predictive analytic tools in Alteryx, and discussing some of the benefits they can bring to your organization as well. So I'll start off talking about clustering. What is clustering? Clustering is an unsupervised method of grouping similar data points together and discovering underlying patterns. In your organization, you may be quite familiar with customer segmentation models as well, which tend to rely upon demographic attributes of your customer base, perhaps age, gender, income or household income, and interest as well. How does this differ from clustering? Clustering focuses purely upon your data sets and attempts to generate or reveal underlying groups and similarities as well. So the aim is to surface hidden groups within your customer base or your data set as well. So you can use this to inform your customer segmentation models as well. Clustering has a very wide variety of potential business applications. It can be used internally in your data governance efforts, perhaps to analyze your internal data documents as well. You can focus on different attributes, perhaps the content or your metadata, popularity or the audience, the authors as well. As discussed, you can use it to better inform your customer segmentation models, expanding the larger number of attributes that you consider when determining your groups or clusters as well. You can also use it in a delivery optimization method as well, where you might analyze your fulfillment centers, warehouses, and decide to determine the optimal stock levels and distribution based upon your customers' orders, the basket composition. It's also used quite heavily in the marketing personalization space, where you cluster your customer base based upon their attributes and behavioral attributes. And you can also use it for customer retention, where you might be grouping or clustering your customers by their behavior, such as their purchase frequency, the last previous store visit, or their average spend within store as well. So there is a lot of scope to apply clustering for business challenges as well. So just at a very high level today, I'll just walk through the actual process of clustering as well. So within your data set, you initially place your centroids, or the center of each cluster, in initially random locations. Then the method will measure the distance between each center, each centroid, to every data point within the cluster as well. Then it will incrementally shift your centroid towards the average, to reduce the average distance between these points, aiming to move and shift towards the center of each cluster. And then it will repeat this process again. It'll be iterating this or repeating this over and over until the mean distance between the center of each cluster, the centroid, and every data point ceases to minimize as well. Part of every data science workflow is to evaluate your efforts and the performance of each model. So for clustering, to evaluate this, we tend to focus upon, and there are a variety of methods, but we tend to focus upon two metrics. The distance between each data point in your cluster, which for today, we'll be using the RAND indice, which lies between 0 and 1, and we're aiming for a higher score there. And we also measure the distance between the clusters as well. We'll be using the chi indices, and we would like this to be as high as possible. An important decision is to determine the exact number of clusters or the optimal number of clusters. Based upon your situation or your business requirements, you may already know how many clusters you're searching for or have to apply, but it's also important to analyze your data sets to determine what may be the optimal number of clusters. So for today, I've brought along some real-world data, a sample data set from the Melbourne real estate market, covering the period of January 2016 to October 2018. This is a housing clearance data, so this represents actual sales, and we have approximately 49,000 actual properties as well. And we have the fields that in our data set here on the left as well. So an important part before we apply any model or any technique is to conduct some exploratory data analysis in here. And so I've just had a quick look at the price versus the distance, each property's distance from the CBD of Melbourne, and also the number of rooms for sale in each property as well. So now I'm going to switch over to Alteryx. Okay, and walk through some of the tools that I'll be using to achieve this. In here, I have my sample data set stored as an Alteryx database as well. And then I've applied the K-Centroids diagnostic tool as well. So within here, I can select which fields to consider for my clustering analysis as well. I've included all of them, or all of the numeric fields as well. I've also standardized the fields, and this is an important part of every clustering analysis effort, because the impact of each field has to be taken into account. So an increase in $1, say of the price, will not have as much impact or shouldn't be considered as closely as, say, possibly an additional kilometre in distance. So we're standardizing the fields within here. It's very straightforward to do this within Alteryx. I've also considered perhaps I want to analyze or consider a large number of clusters, and I can utilize different clustering methods. K-means is the most common or most widely used, but I have other options as well. I can also adjust my plotting options for the output as well. After I've conducted my initial diagnostics as well, I'm presented with a K-means cluster assessment report. And this lets me determine the optimal number of clusters for this particular data set using my parameters. In here, I can quickly see that the RAND indices, which represents the intra-cluster distance as well, I can see that the mean in this box plot, that the mean for 3 clusters is much higher than the mean intra-cluster distance for 4 clusters. And the chi indice, the mean in here, is representing that there's a greater distance than 2 clusters, but not as much as 4 clusters as well. Now, there's no exact way of determining the appropriate number of clusters, so you have to make a decision within here. There are other methods that you can utilize, the silhouette method as well, which we can cover in a later webinar. But for today, I've decided that the 3 clusters is appropriate for my data set. Now I move on to my cluster analysis and actually use the cluster analysis tool as well. Okay, and I've included all of my numeric fields to be clustered. Again, I've standardized all my fields and I've decided to apply 3 clusters. Again, I have plotting options within Alteryx for my actual output as well. And then after I've applied the clusters, I can start to see some summary statistics as well. So I can see that in one cluster, I've placed 22,000 properties, and I have my average distance from the center of each cluster. And for this, today, I have required 37 iterations to reach this clustering as well. And now I can proceed to actually append or apply the clusters to my original data set. For that, I'll be using the append cluster tool. In here, it's very straightforward. And then I can actually inspect. I have some data profiling options as well. So I can see, browse my data set quite quickly. And then for today, I've output my clustered data set into a Tableau hyper extract. Okay, now I can see the effect of my clustering analysis in my exploratory data analysis. I can see that my data set has been clustered here in 3 as well. It's my higher priced properties closer to the CBD as well, and across the different rooms as well. So you can notice that the boundary isn't very well defined in here because I've included multiple fields in my clustering analysis as well. Okay, whoops. So the benefits of performing clustering analysis using Alteryx. What you've just seen can be automated and scheduled and performed very frequently using Alteryx Server. So this clustering could be performed on a weekly, daily, even hourly, perhaps every 5 minutes. So you can track the impact or the changes in your data and how they're reflected in your clusters. We might decide to experiment further with different variations of the clustering. We may decide to compare different levels of clusters as well, or utilize different methods, either k-means or k-medians, neural gas. You've seen that it's very, very easy, just selecting the options. We might also decide to examine the effect of including or excluding different variables as well. We can track the movement of our customers or items or data points between the clusters over time, and we can identify the emergence of new clusters as well. Most importantly, we can distribute this information throughout our organization. We can use this to enrich other data sources and use this in future analysis as well. And this can be repeated by non-technical users with some minimal training and experience as well. Okay, so I may hand this over now to my colleague Alex to discuss time series forecasting.
Thanks for handing over to me, Blake. Hi guys, thanks for being here with us today. My name is Alex Carvalho. As Blake introduced it, I work as a machine learning and data science consultant here at Billigence. And now I'm going to share my screen, and because today we are going to have a look a little bit about time series forecasting. Yes, so we will have a look at the main robust models for forecasting from Alteryx, a walkthrough on the main steps of a forecasting workflow, some trick parts to be mindful before forecasting on the pre-processing steps, and also some tips about how Alteryx can help us building reliable forecasts. So time series forecasting has been around us for thousands of years, and people in the past who had what was considered the gift of forecasting the future were considered gods by many. Actually, even nowadays, if we consider the recent markets disruptions and fluctuations, A lot of people probably might think that only gods could have forecast that. Jokes aside, for sure, those harnessing the power of forecasting are having great advantage planning and meeting their demands of these very uncertain times. So what is it? To put it simply, time series forecasting is the use of statistical models to predict future values based on past observations. And although we know it's hard to predict the future, we also know how important it is to understand it, because it can help us prepare for the future time we want to predict and make informed decisions related to, for example, stock and inventory management, managing staff across many stores, pricing accordingly so we can keep sales profitable. And actually, any variable that can be tracked and collected over time is a good candidate to be forecasted. The use case can be just about anything, you name it, like monthly visitors data, sales figure, and quarterly, monthly, or for any specific time, energy demand in a specific region, like Sydney, by a category of fuel, for example, or data sales in a wholesale market in Perth, or even the emergency room demand in Melbourne because of COVID-19. And for each of these examples, the data would be collected over time, and a time series model would simply use that data to forecast future values. But be mindful. I know we are saying that you can forecast just about anything, but everybody knows forecasting has never been easy, and people have always had a hard time doing it. In fact, one thing that's very important to be mindful is that usually is the reason why forecasting scares and causes a great deal of pain to a lot of people, is that each forecasting model follows some rules and assumptions because of the math going under the hood of each one. And that means that in order to make use of past forecasting practice to get reliable predictions, we need to understand what is going on with some methods that look more like art than science. And one method to do it is by looking at the composition plot and understanding the patterns underlying it, and telling the model how the time series data behaves regarding these rules and how it should be transformed regarding expected assumptions in order to correctly leverage all the forecasting power of each particular model. We are not going to look deep at this part today, but visualizing the plots still is one of the best ways of doing it. And that's not completely hard for some data sets that show clear patterns, but can get very complicated for other situations. And at the same time, it's not easy for untrained eyes. The great news is that Alteryx is super flexible to deal with that and can combine the best of both worlds for experts and people just starting out with forecasts. Having both of them producing reliable forecasts either way. If you are the forecasting expert at your company and you want to read and understand the underlying rules and behaviors in your series, you can quickly produce many models customized to your taste. On the other side, if you're just starting, Alteryx statistical automation based on the R language can do all the hard work for us and at the same time produce reliable forecasts. Now, let's jump into Alteryx so we can understand how it can help us better. Okay, just a second. So here on the top, we have a whole set of time series on the time series tool tab. I'll show you each of the 5 tools we are going to have a look today, which are these ones: ARIMA and ETS, our models, the TS compare, the TS plot, and the TS forecast, right? So about the first two, the ETS and the ARIMA model. A common question everybody asks is, when should I use one over the other? So the answer for this question is that we should use both because they are very robust and complement each other for investigating a wider range of fit and possible generalization of our data. The ETS, which is this one, a brief description of the ETS is that is the exponential moving model. Is a simple model that fits our data with exponential weighted moving averages. In very simple terms, it gives more emphasis to more recent dates and that exponentially decays towards older data. So it gives more importance to recent dates and decays to when you go towards older data. About the ARIMA tool, the abbreviation stands for Autoregressive Integrated Moving Average. It is a linear model, and it fits the data through correlation among the most recent date and legs of itself. It assumes our data is stationary before fitting the model, and a stationary time series is a series where the mean and the variance are constant over time. So the two models are the main stars in our forecasting toolbox. And now let's go to the workflow so we can talk about it. So this workflow, I prepared it with monthly visitors for stores. And the data set is from 2007 to 2015. Our main objective is to create a forecast model for monthly store visits, to explore the series further with TS plot if we want to customize our model, to run both models so we can fit the best model to our data, to compare both with the TS compared to, and choose the final model, and then forecast with the TS forecast. So in our workflow, if I can show it here, the first step would be to have a look on the TS plot, where we just need to choose our target field. In this case is number of visits, and then the target field frequency, in this case is monthly for this data that we have. And then the plot time, the more complete is the time series plot is the one we are choosing here. So with this, you would be able to find that that the composition plot that I showed on the slides, where you would have your time series data here and here. And here under the composition plot, you would have the decomposition of the seasonal, the decomposition of the trend, and then you can analyze these and realize that this one is a multiplicative pattern, and then this one is an additive pattern, and then the error, the composition is also multiplicative because of these peaks and lows. And then as we are on the ETS, we are on the TS plot, we would also have a look on the autocorrelation plots for the ARIMA tool, and where you can see the correlation of the most current data and legs of itself. And also realize that it's not stationary at this point, that we would need to do some differencing calculations in order to get it stationary. And also you could also have a look on the season plot and then understand more about your data. Everything is interactive. It's important to say that this is very, if you want to customize your model, that's the best place to go because you can have a look at everything in the same place. And now I'll go back there, hoping I don't close everything. Yes. So after we have understood the patterns in our data, we split the data between a training set and a test set. In this situation, I left 12 months for the test set, and then we fit the training set in our models, so the ETS and then ARIMA here. And then on the ETS, you're gonna have to choose your target variable, visits monthly again, because it's monthly. If you wanna customize, And after having had a look at the TS plot, you are going to choose the patterns of the error type. I remember, I think it was multiplicative. The train, I think it was additive. And if it is over forecasting, you also can choose the trend dampening, but you can do it after having a look at the first run. And also the seasonal type, if I'm not mistaken, was multiplicative. For this training purpose, we are going to leave everything on default and then have a look on what will be the outcomes of the model. For the ARIMA tool, have I gone through all of them? Sorry. Yeah, I forgot. Yeah, I forgot. And we also can choose a specific information criteria for model selection. If you leave on auto, you can have access to all of them in the interactive report. You can also tweak some more other stuff to make your model even better for some situations with the box-Cox transformation. And you can also, it's good to check this and to put the right time, your time series start, because on the report is going to show on the x-axis of your report, the charts on your report. And also the number of periods to including the forecast plot. In this case, we are having a look for 12 months forecast, so that's why it's just 12 months. And also you can select the date format or week format in this case, and graphic options as well, but we are leaving everything on default. The ARIMA tool is not going to be very different in some parts of like the ETS. So you are going to choose the same default option, the same options here, which are our interest in this situation. On the model customization, that's going to be very different because they are different models. As I said, they complement each other. And as it is a linear model, the ARIMA tool is going to have some more options to tweak because it can get more complicated. And so you would have for non-seasonal components, you would have all these things that you could tweak. So in this case, the P stands for the autograph part and the Q stands for the moving average part. And also the differencing that I spoke about when you have correlation in your data series. So then you need to work out the differencing until you get it on an accepted level of stationarity of your time series data. And you also get to choose your information criteria. I'll talk a little bit more about in a couple steps about the AKK information criteria, which will be our main guide to look when you are comparing time series tools. And if you have a completely user-specified model, you get to tweak if it's seasonal, so you have a more complex model, then you get to tweak the seasonal part. And if it's not too complex with the correlation on seasonals, you get to tweak just the first part of the correlation between the dates, between the points and the current date. You also can choose to allow drift and also use the box-Cox transformation if you need to go further on customization. The other options are pretty standard, the same as the ETS, and I already explained. So now let's have a look on the interactive part of the ETS, which was the first one that I was talking about. The interactive report actually is better if I just open here. Yeah, so here you are going to have access to a range of error criteria. We can talk about all of them, but it has to be another time. But usually you get to have a look at the main important ones that I would say are the mean absolute scale errors, which is a very important metric when you want to compare different time series, which is it's a very good metric, and also the root mean squared error. But for some use case, and it has to be a case-by-case situation, you would, in some problem definitions, you would get to choose different metrics like mean absolute error, mean percentage error, or mean absolute percentage error. And what I would like to say that I told you guys that the main guide to look at is the AKK information criteria. So that's our guy. So usually this guy is, it shows a trade-off between the goodness of fit of our model and the complexity of our model. So what does that mean? It means that if you have a model that has a very good fit, it's going to be great, and it's going to pull this metric lower, which means that the lower the metric, the better. But also, if this model is less complex, our model is better as well. So it will also get the metric lower. So when it doesn't have like a right number, it is a comparison metric. So what we have to do, we have to look at this number for the ATS and this number for all the other models, other models we have in our workflow. And then if they are really close, then we are going to look at the error metrics. So in this case, our ATS is 1414. So now I forgot to show that the interactive report is really nice, because you can do all this stuff and then look further on some spots. And then you also have the confidence intervals, and the shaded blue, the light blue is 95%, and then the dashed line is 8%. And then you can tweak these as well and change to your own taste. Let's have a look on the ARIMA interactive tool. Yep, and that's us. Yeah, so as I said, because of the correlation plots are really important to us, they will be shown here. And I don't know if you guys had seen, but we had a lot of correlation when we were having a look at the data set on the TS plot, and now they all faded away and are like some of them are around, but it's okay to be around the 0.2 and minus 0.2. But they were like a lot more than that on the TS plot. We could see that the differentiating methods are worked out, and then it's better now. So I don't know if you guys remember, but it was 1414, and I said to you that the lower the better. So in this case, our ARIMA tool has a very better AKH info criteria. So it means it fits better and is a less complex model for this situation. And I don't remember the metrics of the ATS, yeah. But I know that being less complex, if in fitting better our series of data, it's going to generalize a lot better on unseen data. So that's why that's the main metric you have to look at. So here a little bit more on the workflow. We would get an union tool, so we can feed it on the TS compare. So what the TS compare does, it get our model and get the test data. So it's just on Wi-Fi here, so I wouldn't be crossing over the workflow. It gets the test data, we split it here, feed here, and then we try to generalize on unseen data our models. And then there is, let's see what we can tweak here. It's just a plot or base. It's all right, it's nothing to care about. This is the main report. We also have the interactive one. Here it shows some records and which were the predictions for these records. This is unseen. These are unseen data. And also the metrics, the main metrics that we just explained. And here both models, how they generalize on unseen data. But I'll show the interactive. I think I need to run a little bit more. So here is how it looks like, both models. And then as we chose, because of the AKH criteria, we chose the ARIMA. We are going now, you just need to copy from here and plot somewhere where you can connect a new source of data, because instead of getting the training set, we are going to get, now that we know that the ARIMA generalizes better on unseen data, we are going to get our whole model to train our model, our whole data set to train our model with the full data set, like here, like it is here. And then we train again with the full data set. Just checking. You can see that is a different criteria, but we don't have to consider because now we are training with the full data set. And if we would like to compare for both models, we would have to train both on the full data set. And this is the TS forecast. So we select the chosen model and plug into the full stored data set and the TS forecast. Here, the TS, we can choose our percentage value of the larger confidence interval and of the smaller confidence interval, and the number of periods into the future to forecast, which is 12. Show this one shows all the upper and lower bounds of our confidence intervals, and this shows our prediction. Yep. So this is an unseen data. So we have data only until here, and then it's just the ARIMA model, and that's our forecast. So I think I spoke on. The only thing is that on a big scale, you would do, and if you want to customize, you would do this interactively. So you choose, and this is something that I didn't mention that I will show just quickly. You can get to see on the PDF report, you can get to see what were the parameters our model chose. In this case, we had a multiplicative, as I said, on the error, on the train we had additive, and then on the season we have multiplicative. So that's also a good way of training when you are learning about these things. And on the PDF report of the ARIMA tool, we also see that it considers seasonality. It had to do a differentiating in seasonality once, and also had to do a differentiating on the common non-seasonal data once. It shows a moving average term, and it shows an autoregressive term on the seasonality part. And this 12 is just because we are considering months in a year. Quickly, so I finished, but I wanted to show something, which is about when you choose to work with more complex models, or when your data scientist or yourself want to train more complex models. You can also do the same thing for nonlinear models as well, or when you can leverage the Alteryx community applications, because a lot of people post their models there. And also, if you want to use neural networks on the nonlinear models, you can get to do that as well. This is just a simple workflow where I am showing just that I got an application from the community, and then it was actually developed by the Alteryx guys, and it's uses the model, the profit model. I don't know if you have heard about the profit model. It's a model made by the Facebook AI research team, and then it's a nonlinear model. And then this workflow was just to and talking a little bit more about the model. It's a good model to work with daily data sets or daily time series, and it was developed by Facebook for this purpose because they wanted to get holidays during the years, or campaigns and their influence daily, this kind of events going daily. And here I just built this workflow with default settings. I just show here, but default settings where y is my target variable, and here is my date field. I'm not showing them, but this is I forgot to mention that I'm trying to run. Sorry guys. It's a drugstore daily sales. Yeah, I'll go a little bit slower. Sorry.
That's all good.
It's a drugstore daily sales from a chain of drugstore in Germany. They have around, I forgot, it's 7,000 stores. And this data is from January 2013 to July 2015, so 2 years and a half data, worth of data daily. And And here I also did my split. I wanted to predict 61 days, so that's why I'm filtering on with these settings. And here at the model, I can tweak as well, the same way as the ARIMA and the ETS. And then choosing if I want to include holidays or not. If I want to include holidays, then I can select the holidays of the country. And then in this case, it is Germany, but it's not this one, it's the next one. That's why I'm choosing not include a holiday for this one, because this is the one with Germany. And if you want to customize, you also can customize some iterations through the deep learning, the neural network, and also some manual parameters. And I'll just leave on default everything. And here you can check what the model picked on the trend, weekly patterns that it picked, and yearly patterns as well. So it probably, this is Christmas, I don't know, around here, preparing for summer kind of thing, Easter, somewhere here. Here it's the chart showing. I'll talk a little bit more. I just prepared to show a little bit about this, not to go too much further, but this one shows very nice the patterns about the holidays during the year, and these I could say Easter, summer. Still remember what we get here, but probably in Germany Oktoberfest, and here Christmas, something like this. And yeah, that's it. Here we have an option, the same way as with the TS plot, we would have an option of optimize our hyperparameters. And then to do that, we would just get to do an auto parameter tuning, and then we would choose how many iterations we would like our neural network to go through. And then from there, it's going to give you a report about what would be the best settings for the situations. But don't think it's that easy. It is not out of the box. We would have to calculate our metrics to check the data and the error metrics, which are here. If you can see the profit without holidays, it has a little bit higher errors than with holidays. So with holidays is better. And here's just a comparison about ARIMA and ETS, which are a little bit more simpler than this one for daily, how they would work out. So we got to see that the profit with some tunings of the hyperparameter optimization would have a little bit lower errors than our ETS and ARIMA. And the ETS was a little bit better than the ARIMA model. I'm sorry it took very long.
It's a complex topic.
Yeah. And now we're back here.
Yeah.
So where Alteryx can help us the most? So it surely, the big point is that it integrates your whole team, providing reliable forecasts for experts and for people that just started with its automated statistics. Experts can go even deeper, customizing more complex linear models, or even using nonlinear models if they want. They can use the neural networks tools. They can use both Python and R SDK tools to build just anything they want. A range of different applications from Alteryx incredible, awesome community, like the profit we've just seen from the Facebook AI research team. You can save a lot of time turning data science tools accessible to non-experts and generating multiple forecasts for any period and taste of customization, getting everyone upskilled together because it's very easy to communicate non-experts with experts. And you also have like the big benefits of automating everything, ability to use much large volumes of data, and also having a lot and multiple data sources feeding your whole workflows. I'm sorry I spoke a lot, and now I'm handing over to Blake.
Cool. Thanks, Alex.
Thanks, guys.
Cool. Okay, so now we're just going to hop over to linear regression. Okay, so linear regression is an extremely common approach to modeling the relationship between a dependent variable and one or more independent variables. You're probably quite familiar with this from school, university, or you've seen this in your day-to-day roles and responsibilities as well. It's extremely common. It's also extremely versatile. It can be used to assess marketing effectiveness, analyze pricing and promotions, operational efficiency, even assess risk, evaluating trends, sales estimates and forecasts as well. It's extremely versatile. So we'll be looking at simple and multiple linear regression today. So just focusing on the diagram here as well, kind of some key points that we want to focus upon is the intercept as well, where we're crossing the y-axis, and the slope of the red line as well. So we'll be kind of looking through this as well by coming back to my original data set now. So we're looking back at the Melbourne housing clearance data set, and today I'm interested to identify a possible relationship between the fields of sales price, my target variable, the distance from the CBD, and this time I'll be looking at the property type and also the number of rooms. So again, I've conducted some high-level exploratory data analysis using Tableau in here as well. We can see there's a large variation between the properties and the final sales price. Okay, so I'll be hopping back to Alteryx now as well, and back to my workflow in here. So I've got my original data set with no changes. However, because I want to include property type in my analysis, it's what's known as a categorical variable as well. And now I've just, using the formula tool, I've assigned an integer to each type of property. Okay, now it's important to continue my exploratory data analysis as well, and I'll be using the association analysis tool as well. So in here, I've got some options beforehand. I'm targeting price. I'd like to conduct some more detailed analysis of that particular field, and I'm including all my numeric fields. And you'll see in here that my property type, which I've converted into numeric as well, I can include that. So now I receive a report as well, and I'll be kind of looking through this at the different variables that I want to include. So I'll be looking at, say, rooms in here, and these 3 stars indicate that it's a statistically significant field as well. And I can also see that by my p-values being 0, and I'm looking for anything that's below 5% as well. I can also see that postcode doesn't really tend to have a strong relationship on its own to the final price as well, which makes sense logically that there are so many different types of properties as well. Just moving across here to the correlation matrix as well, I can start to see, I guess, the level of association. So I'm looking across here, the price, okay, and I can see that there's a strong relationship in the number of rooms to the final price. I can see that the postcode has a very small impact, almost negligible. I can see that the number of properties for sale in the same region tends to have a minor negative impact on the final sales price, and also increasing the distance appears to have a stronger negative impact on the final price. And then in here, my type, property type as well. So, okay, so looking at these, I've considered these 3 fields as well. I'm going to be looking at rooms, property type, and distance. Okay, so now I bring this across and bring in my linear regression tool as well. Just hop back in here. Okay, so I'm targeting price, and I'm going to look at each variable on its own. So for this one, I've just selected just rooms as well, and I can go in and I can customize my settings a little bit further as well. So I can decide to omit a model constant. So this would be perhaps based upon your business requirements. We want the intercept to begin at 0 as well. We may wish to weight a variable. So if we know that that has a more important impact on our target variable, we may decide to regularize. So this is similar to what we covered in clustering analysis as well. The impact of the actual variable. So where we consider perhaps $1 versus 1 kilometer as well. We have two different types of regularization, which I can cover in another webinar as well. And we can cross-validate as well, which is where we're testing our line of best fit on our actual data. And the number of times or the number of subsets of our original data that we want to consider for validation. We can divide that and validate our line of best fit. If I've decided not to regularize, I can still cross-validate. So really I'm evaluating my line of best fit on my actual data. I can break it up into subsets and conduct it the same kind of validation or assessment the number of times as well. So I can also have my standard plotting options as well. Okay, so these are all set by default. Okay, Alteryx has chosen what are the most appropriate defaults as well. So you don't have to necessarily worry about these. Now, when I run the tool, I get it produces an actual model object, which I'll be using a bit later, and an actual regression report in here. So just considering price versus rooms as well, we have our intercept in here, almost like we could consider this a minimum price. And then we can roughly see that increasing the number of rooms may add approximately 260 to the price, but we're looking at the errors, and also we'll come back to the valuation, but we're looking at this R² value, and it doesn't necessarily seem to be a great fit as well. I can head across in here, and I've taken a screenshot, in here of a more detailed summary as well. Zooming down in here, we can see our correlation coefficient, but really what we're looking at to evaluate here is the mean absolute percent error. So this is 41,000%. So it doesn't really seem to be a great fit as well. But that's okay because we've got other variables we can consider. So let's inspect them. Okay, so now I'm again looking at price versus distance. This could be perhaps more promising as well. I go back to my regression report, and we'll notice we've got a different intercept now and a different distance. This could be suggesting that perhaps every kilometer, as we move away from the CBD, is taking possibly $20,000 off our final sales price. But we can see that the correlation is it's not necessarily that strong as well. So let's have a look now at the summary report again. Here. Okay, and it is a slightly better fit. We can see this is much lower compared to 41,000 as well, but there isn't necessarily that strong of a correlation. So let's keep going down, and let's have a look finally now at price versus property type. Okay, you notice we're receiving different intercept values and different slopes as well. We can also see that, yeah, there's some interesting, or slightly not that strong a correlation as well. But let's have a look now at mean absolute percent error as well. So we're using a percentage in here because of the this absolute value would be saying that it's our line of best fit could be around 380,000 off some of the actual data that we're seeing as well, but we express that as a percentage, so it's a bit easier to compare the regression between the different variables as well. Okay, so none of these are really on their own telling a great story and aren't necessarily that usable. So, but it's okay because we can head down, and it's very simple to conduct multiple linear regression. And that's as easy as including additional variables for our analysis in here. I could customize this further, but let's have a look now at the report. Okay, so we can see now the intercept has changed, and we have, because we're considering multiple dimensions or multiple variables, we have different slopes in each for each variable as well. We've got a higher correlation as well. Okay, and let's have a look at the summary in here. Yep, and we're looking at the errors looking a little bit lower as well. So this isn't necessarily our final destination, but it appears like we're getting a better fit with our linear regression. Okay, our line of best fit. And finally, we want to use the scoring tool. So this is where we actually apply our line of best fit. We could use our local models that we've applied here. We could also use Alteryx Promote as well. We can decide whether or not to use nonlinear regression as well, depending upon the data. And then finally, we just output this into a Tableau extract in here. So let's have a look at the impact. Okay. So when we apply this back to our original data set, we can see that it is not perfect, but slightly better. We can start to see, just looking at price and distance, we can see multiple lines of fit, and that's because best fit, because we've included multiple variables for our analysis. We can see a pretty clear trend as we increase the number of rooms. It can result in a higher sales price as well, but it doesn't necessarily explain the variation just on property type alone. But we've been able to conduct multiple linear regression very quickly and assess the impact of different variables. Okay, so as I discussed, it's very important to evaluate linear regression as well. And this is something that Alex touched on briefly as well, in terms of underfitting or overfitting a model as well. This is a very important part of every data science workflow. If we underfit our data set, we may be missing out on important variables, which is why it's critical to conduct that association analysis as well. A line of best fit may be too simplistic for practical use, and we may need to vary our actual regression method, perhaps using nonlinear regression as well. Now, if we keep adding more and more, it's tempting to add more and more variables as well, but then we run the risk of overfitting to our data set. So that will result, that's a pretty dangerous error as well, because we wanted to apply our line of best fit to unseen values as well. So to evaluate that, we've been looking at the mean absolute percentage error as well. And we're also looking at our adjusted correlation of coefficient as well. So this is important that we use the adjusted, because if we use just a correlation coefficient, as we add more variables, this will increase. So we want to use the adjusted so we can account for multiple variables in our analysis as well. So from here, we might also decide to withhold a small sample of our data set to test our line of best fit as well. And that's very simple to do, to achieve using the Alteryx sample tool as well, which we can cover in another webinar as well. And yeah, so have you seen, like, I guess the benefits here of performing linear regression in Alteryx? We've just applied this in a very simple data set, but there's nothing stopping you using larger volumes of data, perhaps a longer date range, increasingly larger numbers of variables to achieve a higher accuracy regression as well. And we can automate this analysis as well using Alteryx Server. We could perform this regularly, weekly, daily, hourly, by minute as well. And when we have that line of best fit, our regression data, we can automatically distribute that throughout our organization. So we could send out Excel files, CSVs, write it back to tables, and we can use this to enrich other data sources. So we could compare this, use this as an input to other analysis as well. And as you've seen, it's relatively straightforward. So we can put this in the hands of non-technical business users as well. So don't be too intimidated as well. And I think we're kind of starting to reach the end here. So I just wanted to kind of, in summary, say that, today we're kind of taking you through clustering, some k-means clustering, where we've assessed the optimal number of clusters from our data set, and then how to evaluate our clustering analysis. Alex has taken us through time series forecasting with ARIMA and ETS, and also demonstrated how we can incorporate cutting-edge forecasting methodologies within tools and provide them to non-technical business users. Use them, compare the methodologies as well. And we've also had a brief look at linear regression, simple and multiple linear regression. We've examined or evaluated different variables as well, and how we evaluate the results of our linear regression. So hopefully that's been helpful and kind of demonstrated some of the predictive tools. Just like to kind of introduce the concept here that we've looked at these in isolation, but there's nothing stopping you from using these in coordination in a single workflow. Perhaps you may want to perform time series forecasting on a cluster level for individual clusters, and also for your overall time set. That you may also want to examine business drivers, the impact of different business drivers or variables upon each cluster individually. You may want to assess the impact of altering different business drivers, how they may shift your data points between clusters as well. It depends upon your business requirements. And we've only looked at a couple of tools here. There are many, many tools in the predictive tool suite. And also additionally in the Alteryx gallery, there are new tools being added every day. And you can also create your own and share them amongst your colleagues in your organization as well. So there's a lot of potential in here. We've really just scraped the surface. So we might just take some time to have a look at some Q&A, some questions we got through here.
Yes.
Okay, so what should I do when my linear regression is overfitting the data? Okay. Okay. So.
If you have your linear regression, if you have your model overfitting your data, you can select, as Blake said, you can select the customization. In the customization part of the linear regression, you can select the regularization, and there you'll be able to apply any penalty terms you want. You can use lasso and ridge regularizations. Both norms are there, and you can even combine the best of both, having all of them. That would be my answer to tackle down this one.
Yeah, so you can maybe kind of look at removing any kind of outliers as well. Maybe that's something we didn't really cover as well. That's pretty important for like clustering and forecasting. We haven't really touched upon even the data preparation capabilities of Alteryx as well. But you may wish to kind of go back and kind of curate or kind of clean your data.
Select new variables.
Yeah, you can kind of create new features as well to examine that impact as well. So there's a lot of potential. What else do we have? Yeah, we can definitely provide all these workflow files and the presentation at the end. Definitely we'll export everything so you'll have the actual data within there that we've used.
We have another question saying, for TS forecasting, if we apply both ARIMA and ETS models, how do we interpret the results to decide which model is better for the data set in question? I think that I said in the presentation that they complement each other, and then you really want to look at both of them running through your data.
Yeah.
Because not necessarily you will have the best just trying one, so it's better to have both of them and then compare with the TS compared to.
So that's where you look at the AIC, right? So you're generally looking for a lower score there.
Yes.
Yeah. Because I think that's what Alex kind of mentioned in passing, is you can add more and more parameters, but then you run the risk of overfitting your data as well. So
yeah, exactly. Look at the AIC, and then if they are really close to each other, you look at the error metrics. Can we get this Alteryx workflow? So this has been sorted out.
Yeah, we'll definitely provide that.
Yeah.
The performance. So we looked at the mean absolute percent error as well, for the linear regression, how are we assessing the performance as well. So we're looking at the errors, the residuals as well. We want them to be quite close. So there are different metrics we can use, but we were looking at the mean absolute percentage error as well. And then we're also looking for a nice correlation as well. So,
and it's on a case by case, right?
Yeah.
And then you might find out that for some case you're going to look at root mean squared error, which is a big standard in the industry. So probably for each case, you're going to have to find the best metrics for your use case. and we can provide consultancy on this as well. How do we assess the performance of simple?
Yeah, that's what we just went through. Yeah,
okay.
how can the best fit be monitored if it's automated in a frequency? Well, that's good. So what we'd probably do there is, if we were running that example, that sample workflow, is we'd probably be adding a timestamp as well. So every time the workflows run, we have a timestamp, and then we append that data to our data source. So we could actually track that line of best fit moving over time.
The error metrics as
Yeah,
well?
yeah, and the error metrics. Maybe we want to add like some thresholds in there as well. So if the line of best fit is kind of breaching a threshold, we could be notified immediately as well. So yeah, so we could kind of get like an email, hey, the regression saying something's going to go really well or something could go wrong. So yeah, it depends on your business situation as well. We're more than happy to assist in any way, kind of work through that situation.
And yeah, and I think it's also important to stress that this model, they fit very, very well together. So I think Blake said that if you use your clustering to find out which would be the best segmentation of your data, of your customers, of your stores, and then after that you want to open new stores, or you have new customers coming in, and then you want to figure out how would be the sales for the new store. So you would apply time series forecasts, training on the data that you have and the clusters that you have before. So you would train exactly on the same segment that you'll be opening new stores, and then it would make your life a lot easier to forecast new sales, new numbers for your new stores where you don't have any track history.
Yeah, and maybe we can change like kind of perhaps some pricing, some promotion. We try and estimate the impact of that in different clusters. We'd probably iterate through these to kind of gain further insight, achieve our objectives as well. You'll definitely kind of keep iterating. Each of these on their own is not going to kind of provide a kind of final answer. It's really exploring, kind of surfacing the insights, kind of working together to achieve your objectives as well. Adding more data
and
assessing the data, evaluating. Yeah.
And another good thing is that anything you guys really need, we are here to help.
Absolutely.
To customize to your need, to provide some guidance, to sort some doubts. Whatever you need in this space, you can trust us.
Yeah, we can leverage a lot of best practices that we've used across different kind of clients, different situations as well. We're seeing a kind of pretty wide variety of data sets as well, and we're just very interested and keen to help. So so we might kind of, unless there are any more questions, we might kind of finish here. But thank you very much for joining us for the webinar. Hope you've enjoyed clustering, time series, and linear regression as well. We'll be providing copies of these workflows in the presentation, and please don't hesitate to reach out if you have any Alteryx questions, data science questions, or anything at all. We'd love to hear from you. So
thanks, guys.
Cool. Thank you very much.
Thank you.